welcome everyone. This is session number 1 on climate risk and uncertainty. We're going to be discussing very interesting topics regarding how to act despite different ways of knowing. So I'm going to start with a very brief introduction, and then it's going to be followed by additional discussions and introductory terms about climate risk and uncertainty by Siegfried Eisinger and Andreas Hafer. Hopefully I pronounced your names correctly, guys, sorry. If not, a short introduction on different ways of knowing by Werner Krauss. And then I will be talking a little bit about a few examples. And then we will have a general discussion, not only on the examples, but the different ideas. And we have like a few important questions to ask you to guide this discussion. So without further ado, we're 34 now. I'm going to start. So I think that, as I was saying before, we all know that we all make continuously. This doesn't happen like once per week. This happens, if you want, like multiple times per hour, in some cases even like per minute. And we make decisions that are always permeated by uncertainty. And of course, there are different ways to define decisions and to define uncertainty. That's part of what we want to discuss here. But a very important issue here is that we make those decisions with uncertainty almost instantly without thinking, without having a quantitative model for that. Of course, part of our work is to try to get to obtain the best decisions possible. So in a way, we are all permeated by the way our parents or grandparents or friends or by ourselves, how we have under certain circumstances in the past have learned to make one decision or another, to go one way or another. And that's key. We might be able to name this in a wide variety of names. I'm going to use a particular naming that I commonly use. I'm going to call this traditional knowledge or personal knowledge, which has to do with this experience that I have collected during my life, but also this experience that I have received from other people, from society, from my family, from some friends. And this is definitely helping me to make decisions. Again, you know, we can talk about, as in one of the examples that I will show later, should I marry these people? Should I date this particular person? Should I take this particular job? Should I buy this particular car? It has to do with a combination of different types of information that we are putting together in a conceptual model in our brain. And that, of course, can be helped and is often helped by what we call scientific knowledge. So the discussion here that we're going to see is how, in some cases, we might go more with one or the other, or with a combination of them in order to have the best decisions possible. Because that's what we want, given that we want to face our present vulnerability and hazard, which, as we all know, are components of risk, not only climate risk, but well beyond that. So that is my short introduction for the session. And now, if there are no questions, I think that I want to ask you all just to have a good monitoring of the sample that we have in the room, to change your names, just to add 1 or 2 letters in front before your name. So if you can please do that. I'm going to write in the chat the letters that we might want you to include. So if you identify yourself as belonging to an institute, or your job has to do with policy, please add a P. So in my case, if I want to do that, you know, you can see the example in my name. I have an A from academia and then my name. So if you work for policy on policy-related issues, please add a P. If you work in business or the private sector, let's use a B. And if you work, for example, for an NGO or civil society, add a C. Of course, you can combine them. I guess that, you know, in the general case, there might be some P plus A plus B plus C person. So you are free to write your own equation there, you know, next to your name. That makes you happy, okay? So this is important because we want to understand who we are talking to. And of course, our language will be tailored, will be changing depending on who we have. And it's important also for some statistics that we want to have. Thank you very much. And while you do that, let me please introduce you to an introduction on climate risk and uncertainty. And I think that DNV is leading this one. Are you ready, Andres?
Yes.
Excellent. Thank you very much.
Can you hear me?
Loud and clear.
Good, thank you. So my name is Andreas Haver. I'm a researcher at DNV. My educational background is in physics, but I spent the past 9 years at DNV working with risk management and uncertainty in different and uncertainty. So my goal for this talk is to discuss some new perspectives on risk. So let me start with this image from August this year in Lillehammer in Norway.
I'm sorry, Andres. Apologies. Are you sharing your screen? Because we can still see the session 1 climate risk. Can we check that?
Is it not sharing? Wait, I'm going to check again.
Yeah. Apologies for the interruption. Just wanted to be sure that we see what you see.
Oh, wait. Sorry. I had to click. Now I think you should see it.
Correct. Yes. Thank you very much.
Okay, I'll just take it. Sorry about that. Okay. So let me start with this image from a town called Lillehammer in Norway this year in August. In this flooded part of the town, a developer is planning to build 350 new homes. And they claim that they have accounted for what they call the 200-year flood event when planning this development. And they're not planning to change their plans after this flood happened. So this example shows a common way that risk is sometimes expressed in terms of numbers. And what I want you to think about is, what does such a risk metric really mean? What assumptions is it based on, and does it really give a good picture of the risk? Here are some other examples of how risk often is presented to us. So maybe the most common one is the risk matrix here at the top left, with likelihood of an event on one axis and severity of impact on the other axis, and some categorization of what combinations are acceptable and unacceptable. Sometimes we see the risk matrix categorized in a map, as you see in the middle at the top. And sometimes we see multiple dimensions of risk in a so-called risk radar, as you see on the top right. Sometimes we see plots of exceedance curves showing the cumulative frequency of events of a particular magnitude. And from this one could, for example, read out the 200-year flood magnitude. And sometimes we see risk communicated as uncertainty in forecasts, maybe with some indication of a critical limit of some quantity of interest. But what do such risk metrics and visualization tell us, and what do they not tell us? What is risk really about? So imagine that you need to make a decision. For each decision option, there are some consequences that you want and some consequences that you don't want. And among both of these categories, there are some consequences you know for sure or can foresee with high confidence, while there are other consequences you are uncertain about or may not even foresee. So having to balance different consequences under uncertainty, you would feel some kind of way. And the feeling would be stronger the more is at stake. And in this situation, you are facing risk. And there are more complications here because, first of all, we assess and experience risk differently. I may not want the same as you. Different stakeholders have different objectives. And secondly, I may not know and foresee the same things that you do. Different stakeholders possess different knowledge and have different ways of knowing, as we heard in the introduction. So risk is subjective. So we face risk in many daily life decisions. For example, when deciding how to travel, whether or not to buy a house, when selecting a partner, accepting or declining a job offer, and so on. In all of these cases, we weigh advantages against disadvantages in light of uncertainty. So in relation to climate risk, policymakers, business owners, and the general public need to make decisions considering consequences of climate change and associated uncertainties. The EU climate risk assessment uses this figure to illustrate how climate risk results from the combination of hazards, including climate-related and other hazards, the exposure to these hazards, and the vulnerability to these hazards. And here they use the risk definition from the IPCC as potential for adverse consequences for humans or ecological systems. So the European climate risk assessment will apply the climate risk concept of the IPCC AR6 and follow the risk assessment guidelines of ISO 31000. The ISO 31000 standard defines risk as the effect of uncertainty on objectives. And relating back to my figure, the objectives can be defined in terms of the wanted and unwanted consequences, while uncertainty is the other axis. The IPCC definition of risk as potential for adverse consequences, in that case, the word potential captures the uncertainty. So that is along the one axis, and you have the consequences along the other axis. So in my opinion, this is how these two risk definitions can be related and explained through this diagram. One interesting thing to note is that the IPCC definition is only includes the unwanted or adverse consequences, while the ISO 31000 definition includes both positive and negative consequences. And people often use the term opportunities to refer to positive risk. But from a theoretical point of view, there's no need to separate them. And in some cases, what is an opportunity for somebody could be to some stakeholder could be a risk to another. So it's good to be aware of this when communicating about risk, if you include both positive and negative or only one of them. But how do these risk definitions relate back to how we communicate risk in terms of risk metrics? So the key here is to distinguish the concept from the metrics, or could also say the landscape from the map. So conceptually, risk is the potential consequences and uncertainty in a situation, illustrated here with a group of people walking below a mountain with a big boulder at the top. The concern here is that the boulder may dislodge and fall down on the people below. Uncertainty is about whether it will dislodge and about the impact if it does. So you could ask a geologist to quantify the risk, and she may say that it's a 1 in 1 million chance that the boulder will dislodge today. But then you could also ask a layperson, and the layperson may actually say exactly the same, that it's 1 in 1 million. But presumably, the geologist can back up her number with scientific reasoning and evidence, while the layperson probably just made a guess. So if you consider the knowledge dimension, the risk is not the same. You would feel more concerned and less confident if the risk assessment was done by a layperson than by the geologist. So this illustrates that when describing risk, it's not enough to provide numbers. It's crucial to include an assessment of the knowledge that went into producing those numbers. And also the fact that you have poor knowledge is a reason to be more concerned and not the reason to downplay the risk. And I think that's also very important when it comes to climate risk. So here's another way to think about this. So any risk assessment involves a series of choices and assumptions. So first, you decide on the scope of the risk assessment. So for example, in the context of climate risk, you may be focusing on natural disasters, such as flooding risk, and not consider other aspects, for example, biodiversity. And once you have defined your scope, you decide on some models and methods to assess these risks. And that always involves assumptions and simplifications. And then finally, when you have done your analysis, you choose how you present the results. And this often includes using some risk metrics, like reporting the 100-year flood events and so on. So what I try to illustrate with this figure is that you lose something along the way, such that your risk metrics never capture the full risk picture. So there are aspects of the risk that hide in the assumptions. And therefore, it's very important to identify and assess the effect of such assumptions in your risk assessment. The challenge is that often the assumptions that you make are tacit. You don't really explicitly state them, and you may be not even aware of them. So that brings me to the end of my presentation. I'll just repeat the key messages. So risk is about the consequences and uncertainties you face in the decision contexts. And this view can be useful in understanding both the ISO and the IPCC definition of risk. Importantly, we perceive and assess risk differently depending on our values and our knowledge. Risk metrics are not the same as risk definitions. Risk cannot be reduced to numbers, although numbers often can be helpful to describe aspects of risk, but it's not enough. because risk may hide in assumptions, and these are often tacit, and therefore uncovering and evaluating the impact of assumptions is crucial in describing risk. So that is the end of the presentation, and then Siegfried, and maybe
hello.
forward.
I'm the colleague of Andreas, and also involved in Climate Europe 2. We see that risk and risk analysis and uncertainty, they cause quite some confusion. And the modern definitions are not commonly used, let's say. And therefore, we want to work more on this theme, both in Climate Europe 2, but also in DNV. And it's therefore important for us to get a little bit more feedback from you in the audience, how you see these various things. And therefore, we have collected a few questions to you. We have, just go to the first, please. We have not been able to do a proper poll like Mentimeter or something. But anyway, we can do that a little bit more simple. So if you now open your chat and give the answer, just the A, B, C for these various questions. So let's start on which of these risk definitions do you prefer? So there are a number of definitions, as mentioned by Andreas already. Is it risk as likelihood times the impact? Or is it more the effect of uncertainty on objectives? Or is it C, risk is the potential for adverse consequences? D, risk is consequences with associated uncertainty? Or do you use it in totally something totally different? So if you could just put an A, B, C, or D in there. And we can later on discuss that a little bit more in our after the break, and we will also look into that and take that into account when we go on working on Climate Europe. Yeah, so maybe we can just go to the next question.
Let's see.
Just next, yeah. So, do you think combining the ISO 31000, there's a 0 missing, and the IPCC the risk definition, as they were mentioned by Andreas, do you think they can be combined? Not at all, which would be A, maybe, or C, yes, no problem. Of course, I mean, if you want to write a sentence in addition to your answer, IPC, that's fine also. It's always good to have some reflection on things. And we can take that up again later on. Right, so take the next one. Are you familiar with the ISO 31000 risk management standard? Which would be this uncertainty on objectives. A, never heard about it. B, heard about it. C, familiar with it, but not used it. And D, I'm using it already. That would be your answer before you heard the presentation. So just very clear about that. Otherwise, everybody should probably say, I haven't heard about it. Right, okay. Thank you. And the next one. What sources of uncertainty, because this term uncertainty, it's difficult, but what sources of uncertainty do you think are most important in the context of climate risk, in your opinion? So there is uncertainty related to policies and agendas of stakeholders. B, there is data quality, which is the main problem. C, natural variability. D, long-term changes. and E, socio-economic context. Here you can actually give 2 letters or 3 if you want. So it could be various things, but focus on the things which you think mostly trigger uncertainty in your opinion.
Maybe we should add the option F, other, as well.
Yeah, that's a good point. Yeah, you can add F. Good. Thank you.
Jean-Ralph, you are cheating, huh? He gave them all. I'm just writing this down, Siegfried, so that we can later have a summary. But
yeah, that's good. Yeah. So let's have a last question, don't we? I think we have one additional one. What is difficult in using the ISO risk definition? Because that's what we observe, that people say sometimes that they use it, they quote it, but in the end they fall in a way back to older definitions, maybe to call it like that. So A, nothing is difficult, I'm using it. B, the definition is hard to understand. C, the term uncertainty is hard to operationalize. D, it is hard to use the definition to qualify and rank risks. And E, I am so used to the old definition. So that's about it. Thank you very much for the answers you gave. Let's come back to it again later on in the discussion. You're very welcome to that. And as I said, we will also go a little bit into it and use it more as a statistics for further work. Thank you.
Thank you very much.
Thank you, Andreas and Siegfried. Excellent presentation, very clear and discussion. We will have time for further discussions later after the break, but it's important that we try to keep the schedule so we don't get, after the hour. So now let me please introduce you to Werner Krauss. I think that most of you already know him from University of Bremen. And he will be talking about different ways of knowing, if I'm correct, Werner. The floor is yours.
So, okay, yes, I'm Werner Krauss from the University of Bremen. I'm a cultural anthropologist. I'm interested in human-environmental relationships. I'm interested in climate change and the effects of climate change on certain areas, on certain landscapes, and how people perceive these effects of climate change and how they deal with it. And even more, I'm the social sciences, the much talked about social science, the first hour. And I wondered the trust in social sciences. I mean, we are all convinced that we need social sciences, which I highly appreciate, and I think that is true. But who are the social sciences? What do we mean by that? Geography, anthropology, sociology, media, communications, which theories? Well, I'm a cultural anthropologist, so I talk from an anthropological perspective. I'm going to talk about risk assessment and uncertainty from an anthropological perspective. I argue that scientific data alone do not tell us what to do with climate change and how to react appropriately to the effects of climate change. There are other forms of knowledge too, and which we have to take into account. It is the sum of different forms of knowledge which help us to cope with risks. But these mechanisms are hard to pin down, and they are place-based. Each landscape, each place has its own way to cope with challenges historically and in the present. This is why we have to learn about different forms of knowledge and how to use them effectively and in the best way. We have heard already about uncertainty in science. Climate change challenges other forms of knowledge too, like local knowledge, tacit knowledge, or indigenous knowledge. So maybe we have to remind ourselves once in a while what the romantic novelist Heinrich von Kleist once wrote. The earth is beautiful, but it's also a dangerous place. Life on Earth is uncertain. It is an existential feeling. We do not know what the future will bring. But humans developed rituals, routines, institutions, and practices which are based and developed on experiences. These forms of knowledge are challenged by climate change too, but they are crucial to make place-based decisions. We cannot rely only on scientific scenarios. We have uncertain knowledges. The question is how to come to decisions, how to assess risks. Well, to give you an example, the North Sea coastline, one of my main field sites, is endangered by sea level rise and its effects on storm surges. But mostly it is endangered by extreme weather. The land is flat, it's just like a bathtub. Large parts are beneath sea level, and the main problem is to drain the land, to bring the water out of the land into the sea. The dikes are climate dikes today, built by engineers, informed by the IPCC, protected by a system of administrations. The drainage system evolved over many centuries of interaction with the sea. The maintenance of this infrastructure is based on local knowledge derived from experience, on so-called customary practices, on tradition, and on national cultures. In Germany, for example, we tend to build walls against the sea. You can see on the photo at the horizon, maybe. We tend to build walls against the sea. In Denmark, for example, they leave things more open and interact in more playful ways with the sea. So science presents matters of fact about sea level rise, data, scenarios, statistics. This is important information, but for coastal inhabitants, sea level rise is first and foremost a matter of concern. You can see on this photo a dike in Lower Saxony with a sluice, a tidal gate to bring the water out of the land, a tidal gate. And you see some landmarks, the stones in front. These are flat stones which demarcate historical storm surges between the 13th and the 20th century. Two floods in the 21st century already were higher than these landmarks. We are talking here about a post-apocalyptical landscape. The apocalypse is not only in the future, it already happened there. 10,000 of drunken people are buried along the coast. The catastrophes are inherent to this coastal landscape and its administrations. It's a long learning process how to deal with it, and it's an ongoing learning process. The existence of this totally constructed landscape depends on this knowledge and the permanent involvement of this knowledge. So we are talking here about different systems of knowledge, or more exactly about different ways of knowing. There are mainly three ways of knowing: science, local knowledge, and indigenous knowledge. Local knowledge is defined by the IPCC. I'm going to read the definition. The understandings and skills developed by individuals and populations, specific to the places where they live. Local knowledge informs decision-making about fundamental aspects of life, from day-to-day activities to longer-term actions. This knowledge is the key element of the social and cultural systems that influence observations of and responses to climate change. It also informs governance decisions. Well, in anthropology, we like to talk about landscapes as the unit of research. Here, in this case, about coastal landscapes. Landscapes are interesting. They are neither nature nor culture. Especially at the North Sea coast, landscapes are practices. They are political ecology. They are constructed in interaction with the elements, the wind, the water, the soil, the sea. We call these practices customary practices. They are like customary law, not really written down. They are partly institutionalized. They are administrations with archives and huge knowledge. But engineers and other practitioners, farmers and our people transmit, or doctors, for example, great parts of their knowledge from person to person and through practice. Dike experts have tacit knowledge, like farmers. They listen to the radio, they read the IPCC, and they look at the sky and other signs they are used to interpret. That is called tacit knowledge. Indigenous knowledge is a different term. It's a more political term. It comes with an entitlement. There are property rights, copyrights, identities. It is a political identity. In many respects, indigenous knowledge mirrors science in the term of non-negotiability of certain items. In the name of science, of geology and weather maps, Europeans and North Americans conquered large parts of the world and used the colonies for extraction of resources, and they still do. Indigenous people are those who lost their rights and now fight back. They constantly remind us that we have to decolonize climate science and climate services. Numbers are not neutral. So, how to deal with these different ways of knowledge, how to come to decisions. I think in the climate service community, post-normal science is a certain house number. So post-normal science applies when knowledge is uncertain, when values are in play, stakes are high, and decisions have to be taken anyway. So cases which science cannot solve immediately. So what to do? Post-normal science suggests extended peer communities, assembling different voices, bringing indigenous voices, local knowledge, administrators, scientists. They have to assemble in certain ways. With climate change, we have to reconsider these form of assemblies. Who is relevant at these assemblies and who is not? How do things change? That is very interesting. We currently can observe these processes. Climate services are a new player in these assemblies, or we want to become one. What we also need is new forms of knowledge quality assessment. How to assess knowledge when local stakeholders express their voices and their experiences. And in the end, we have to bring climate into democracy. Democracy has to change all the time. We always take it as a process. We take it for granted, but it's not. What happens to democracy when climate issues come at the table and we have to take decisions on climate issues? So this is the view from anthropology on risk assessment and uncertainty. I have prepared for discussion some very general questions. Please feel free to answer this question or to contribute to it. It's not really answerable questions. So the one question that really interests me most after the discussion in this morning, what exactly is the role of social sciences and what kind of social sciences? Social sciences are always taken for granted. Everybody thinks it's what is missing, social sciences will answer. But there are quantitative social sciences and qualitative social sciences. Each discipline has a huge theory apparatus and a long history, which cannot be summed up in something that is applied immediately. So what kind of social sciences do we talk about? Second question is how to evaluate different forms of knowledge. And the third one, how to standardize these processes of decision-making. Where does standardization apply in democratic decision processes? For example, is it a standard that everybody has a voice, or who is included, excluded? Is there something to be standardized? So these are my questions. Thank you.
Thank you very much, Werner. Excellent. So we will have, as I mentioned before, a time for discussion, not only the super interesting points that Werner has shared with us, but also the ones that Andreas and Siegfried shared too. So unless there are any burning question right now, keep those questions. We will present them again later, but keep them in mind. And before a short break, let me just share my screen. I assume that I can do that. Oh, I need you, Werner, please.
I go out. Yep.
Excellent. Okay. Let me share my screen so you can, I can go back to a few of these points that we mentioned before. So probably you can see. Can you confirm that you can see my screen? Yes.
Yes.
Excellent.
Yes,
Thank you very much. So I was asked to talk a little bit about a few examples. And because, as we all know, in this Webstival, obviously we're paying attention to a wide variety of climate services and, interested in the community, an equitable community of climate services overall. But also, the processes of standardization, guidance, recommendations, with a particular emphasis on the private sector. I thought that I could talk to you a little bit about these concrete examples on financial tools to transfer risk. This is not obviously something that is only used by the private sector these days, also the public sector and hybrids, but I thought that this could be appropriate. So let me start with something that has been already mentioned multiple times, and I swear that I didn't work on this presentation together with Andreas and Siegfried. We will see a few of those examples that were mentioned before. So as we know, we all make decisions continuously, and those decisions are permeated by uncertainty. Always, there is always. We know how to do this. It seems that we don't know, but we do. We do know, and maybe it's not the best way, and that's what we are here for. We want to identify the best ways. Well, should I marry this person? Should I date this person? Should I take my umbrella today because it's gonna rain or not? So it has to do not only with one type of knowledge as we have been discussing. In general, we live with this big sign of uncertainty all the time. Even if we don't see it directly, we know it's there. So as Werner very clearly explained, there are multiple ways in which we can divide. I don't know if I can call it non-scientific knowledge. Of course, we need to be very, very careful about pseudoscience or fallacies or like facts that cannot be or supposed facts that cannot be proven. But there is a lot of important information and knowledge that we can call local, traditional, or tacit, as Werner has explained. So this is, I think, if you were in the previous session, the discussion with the different international panelists, Carolina Vera from Argentina, she was talking about agroclimatic roundtables. This is a real one that we helped establish back in 2014 in Jamaica. Okay, so these are all farmers in Jamaica. This is a picture by the National Met Service in Jamaica. And of course, we have the other side of things that we trust and we like also a lot, which is the scientific knowledge. And there is this, in my opinion, there is like this belief that they tend to contradict each other. And in some cases, for sure, that happens. A concrete example in Spain and actually in Latin America and the Caribbean is called the cabañuelas. I don't have the time to explain that one right now, but if you know what I'm talking about, we can come back to that one later. But is this like some kind of non-overlapping knowledge? What can be done here? So there are options, there are tested options. There is a lot of literature about this, and there is a lot that is not in the literature in part because some of these products are only in the gray literature or project reports, or even in the private sector in such a way that is not public information. But there are ways in which we can take advantage of these two worlds and try to build the best information possible, I'm going to call it, to make decisions. So some of you already know that we have been working with some indigenous communities, in particular in Latin America and the Caribbean, and that there are several bioindicators like certain behaviors in trees, or when the particular fruit falls, or the behavior of ants, or even birds that are used in this traditional knowledge, indigenous knowledge, local or tacit knowledge. Werner is the expert here. I'm not an expert on how to classify or call them properly, but you know what I'm talking about. The use of bioindicators have been there in the human history for millennia, and they convey important information to the people who can read this information. Not everything is accurate, not everything can be trusted, not everything is reliable, of course, but there is information there that can be used and that provide context. And then we have, on the other hand, these scientific information? Can we actually marry them? Can we overlap them? As I said, there are multiple examples right now, real ones, not academic ones. We're talking about the real world here that show that it is possible. I'm going to show you a couple of them. Both of them are financial tools to transfer risk. We might like go into climate risk only, but you know, I'm going to keep it like as general as possible. So if I tell you there is going to rain, what, I don't know, 23 millimeters the next week, some of you might know that that is the equivalent to 23 bottles of 1 liter in 1 square meter. So when we say millimeters, that might be like too technical or too abstract. A few people will understand what that means. Anyway, we need a translation, a way to translate what science is saying with those 23 millimeters in something that people making decisions, all of us, can act upon. We need those thresholds so we can trigger concrete actions for making decisions. I'm going to leave it as general as possible. So this is a concrete way in which you can get the best of these two worlds by co-identification of these key thresholds. So when you go and ask the farmers, these are farmers actually in Honduras, in Central America. This is actually the outcome of an exercise in Senegal, in Africa. And this is also the same one in Honduras. So something that you can do is that rather than just showing a map or a time series indicating values, you can provide context through this co-production and co-identification by identifying, for example, which years were good or bad in the particular experience of this farmer or that other farmer, because of course it's relative and it depends on the particular crops, the particular demands of the users. So when you get into this type of mechanisms, you can actually get the best of two worlds. A concrete example in this particular case, the slide that I'm showing has been pioneered by the CGIAR. I don't know if you know them, but it's CIAD, the International Center for Tropical Agriculture. It's called right now the Alliance CIAD Biodiversity, has been pioneering in Latin America and Africa this index-based insurance, in which you have some satellite data or the National Met Service rainfall data or some international rainfall product that is used as a reference, as an index that will trigger the payment of your insurance. If you are a small farmer, you are a smallholder farmer, this is extremely important for you because the usual approach will take months, will take a long time for you to get the money back from your insurance. So how this works, this can only work well. We have multiple examples already published in the literature that shows that if the thresholds, these lines over here, are not well calibrated, well defined, if those thresholds are not answering to the actual demand of the farmers, so then this type of instrument, this type of tool to transfer climate risk is not as efficient and the decisions might not be the best one. But this, as you can imagine, for small farmers, this is an extremely useful way to increase your resilience to climate, not only climate change, it's involved with natural climate variability. So just, to keep in mind that co-identification of these thresholds, like this getting the best of two worlds. My grandfather used to tell me this. I remember that this was a bad year. That was the year when my daughter was born. And I remember that we got like terrible drought or terrible floods or a pest in the coffee plants. That is key information to be able to build, to co-produce this particular set of climate services. And as you can imagine, this will lead later to a set of potential standards or for sure guidance or recommendations on how to best produce information that can help us making the best decisions possible. A different but complementary, one will not solve all the problems. Index-based insurance is not enough. And there are a few others. I just don't have time to present all of them, but index-based insurance in combination with forecast-based financing, or also called forecast-based action if you are in in the disaster risk management sector, for example. If you work with the Red Cross, Red Crescent efforts, it's also called their forecast-based action. So this is a complementary risk or financial tool to transfer risk, in the sense that if we have, that's a big if, but we have that in several places and times around the world. If we have good forecast, rather than, something is coming and then I don't have the time because I didn't have a good forecast, and then I have a disaster happening, I ask for help, and then the government or the bank or someone sends me money to deal with this disaster, I'm wasting very valuable time that can be translated in terms of really bad and huge impacts in terms of socioeconomic activities or life of people or infrastructure. The idea of forecast-based financing is that whenever and wherever you have really good forecasts, and that, as I mentioned, that happens, you can advise the government to prepare the money and send it in advance of the situation, of the potential flood or drought, to the local government. Let's, in this particular example that I'm talking about, the national government will send the money to the particular municipality in one of these developing countries we have been working in. And then the money is already there. And when the disaster happens and you ask for help, then the money is already there and you can act faster, which means you are saving more life, you are saving infrastructure, and you're saving money to this country, which is extremely important, especially for developing countries around the world. But this also applies in developed countries. We can talk later, if you want, about several examples for agriculture in Andalusia in southern Spain. So this is another mechanisms or set of mechanisms that are already in place around the world that show the importance of this co-production and using information not only on the scientific side, using, if you know what I'm talking about here, the probability density function, or all the technicalities in assessing risk, as we were discussing before, with how to marry those numbers, if we have an El Nino or a La Nina, those particular numerical or if you want, quantitative thresholds to the experience, the local experience that the farmers or the decision maker had. And obviously that is very complex because it depends on how do you define a bad year? Bad year for respect to what? It was a bad year because there was a flood, or it was a bad year because there was a drought. So it's very complex, and that's why that context can be provided by this hybrid, by this marrying of the two knowledge systems. Obviously more than two, but you know what I mean here. So this is a concrete real example that we develop in Guatemala for forecast-based financing. And then this is another one for Malawi. These things are out there. This is not theoretical or in a paper. This is a real, real world example. So I'm going to stop there. And I think that, this is a brief summary, but probably you already know, everything about it. I don't need to go through those points. And unless there are like major questions, I am going to stop sharing and actually check in the chat. There's nothing there. I'm going to suggest that we have a brief break. In our schedule, we have 5 minutes. I think that is still okay. So we can be back here if you think that makes sense at 12:36. So we can start our discussion on these different topics. Thank you very much. So see you guys back in 5 minutes. Hello, everyone. We will be back in 1 minute, just a heads up. And I can see that there are a couple of really good questions from Roger that we, could also be part of our discussion. We will democratically decide how we want to proceed. Maybe we can start with the previous questions, and then our colleagues from DMV can also present the questions again, and also with Werner's questions, or maybe it's natural just to start addressing the ones in the chat. So
we have actually the answers. Funny prepared them. So we can show the percentages on them. So maybe that's interesting for people to see.
Must I share it?
If you share it again. So
okay, just a moment.
So just a second.
Yeah, then I need to.
We added.
You don't have it open on your screen. Let me just.
No.
Oh, okay, just a moment. I need to find.
Same presentation should be. Oh,
yeah,
no.
it's just that I have closed it down.
Okay, right. Yeah. So it's interesting. Yeah, here we go. Right. You can see that?
Yeah, thank you for zooming in. Yeah, excellent.
So first question, which of these risk definitions do you prefer? This older definition as likelihood and impact is still 30%, and then its consequence with associated uncertainty is 35. So these, and in addition, the C risk is potential for adverse consequences. The rest is little, and of course, even this ISO definition is 0%, which is interesting. Go to the next. So just quoting them here, it's very clear. People think that it's maybe possible, but nobody is really sure. Neither not, nor yes. Here about the ISO definition, and there are many people have not heard about it or just about heard about it, and basically no usage so far, which is not really astonishing for us, as at least as a matter of fact answer. Some people say they use it, but maybe it's not fully operationalized. Right, next one. Yeah, about sources of uncertainty. There people think that policies and agendas are the most important. Very interesting, yes. And then the data quality, which is a major thing for Climate Europe too. But for us, it's also interesting to see that maybe data quality is not the only uncertainty, that there are major other uncertainties around. It's distributed all over the place here, actually, with the policies and agendas on top.
This is a surprising answer, isn't it? I didn't expect it that many % on the A.
Yeah, but and actually, I would even put an additional thing on it. It's rather well known that basically any big disaster has been known beforehand. There are nice books written about that, and that actually makes this point even stronger, right? Because very often risk is very much about, do we want to know, or do we actually put it away? Either politically, or some decision makers know they don't want to know. And therefore, it doesn't surface this knowledge that something could go terribly wrong. One very well-known example is the Vasa ship, which capsized in its first trip, and the problem was known, right? But they went on because nobody wanted to know. Very interesting. So it's agendas and policies are very important. I think I agree. Next one. What is difficult with using the ISO definition? Nothing difficult. I'm using it, so very few said that. And this to operationalize the term uncertainty, that seems to be a big problem. And then this way to qualify and rank risks with that definition seems also to be a problem. So that is actually something we need to work more on. I think it's fully possible to do that, but it seems that people struggle with it. That's important information. Okay, I think that was it. Yeah. So thank you.
Yes, thank you.
Excellent. And thank you, Fanny. That was fast. You did that calculation super fast.
Well,
yeah.
I am a free mentee.
Nice. So this is super important because it's getting into, you know, the threads of this discussion, these topics that come, not only, you know, during the day, obviously during our session, but during our decision-making processes. There are a couple of comments and questions in the chat. Should we address those right now, or should we go back to Werner? We are very aware of the time. We only have 19 more minutes, but I think it's enough time to have a nice discussion. So it depends on how people want to go ahead. I can also decide dictatorially how to proceed, but better if it's democratic. So Werner, are you interested in sharing your screen just for, you know, the sake of
I think Rutgers in the chat has a very interesting question.
Excellent. So Rutger, do you want to please?
This, maybe I read it shortly. Question: could you say that traditional knowledge, as Anchal presented, is the result of more experiential learning, and scientific knowledge is the result of more formal knowledge acquisition, including hypothesis testing? I'm also thinking of the cartoon that Andreas was showing, with the layperson's estimate of the probability of the rock falling shown as weak knowledge. How does this relate to Werner's plea to include these different types of knowledge? I think it's a beautiful question. It addresses all of us. There's so much to say about it. Maybe if I make a start on it, we don't use the term traditional knowledge anymore, because tradition is a concept that is related to a people, to a nation, to folk, and it's completely intoxicated with negative meanings, the word tradition. So it's more customary practices, maybe, things we are used to do. So we always think of citizens as people of citizens of nation states, but that is only a part of our identity. We do not go the official crossways. We cross the street whenever we think it's appropriate because we know how to do this. We are self-responsible people. Customary practices is how people survive in dictatorships, for example. They rely on routines where they know where they get their food from, how they protect their families and everything. So Ancho, you talked about it would be great to have forecasts and the nation transfers monies to the municipality, and even before the disaster happens, people are already prepared. But which nation are you talking about? Is there a nation in the world where money transfer from the government to a municipality?
Yes.
Where that works and it arrives, and then it arrives by the people. This does not exist in the world. So customary practices is how to survive under these circumstances. And the other, only a short note, is to science. We should learn that science is a social practice. It's not neutral. It has a history. So geology, geography, and climate sciences were used to inhabit the colonies, to see which land can we use, which for plantations, which people can we use, so sciences have a history and are not innocent. It's not pure hypothesis testing. It's part of the practice, but we have to see it as a social agent. We have to see which role plays science. Just ask a farmer in Germany. He's permanently advised by scientists how to treat his cattle. Put them in the stable, put them out of the stable, do it organic, do it with phosphor on the fields. Science is permanently intervening because they are linked to lobbies, of course. So we always pretend we are neutral people. We are not. we are really not. We have very good tools, no doubt, hypothesis tested, but we have to see us in a greater context. So people do not have tradition. We are not ahistorical. So we are both actors in societies and have to combine these knowledges. That's my short comment.
Anyone else? It is indeed a set of very interesting questions.
It's almost philosophical a bit. Huh?
Well, as Asuns was commenting, you know, all disciplines are important, including philosophy. So, but yeah, I agree with you, Fanny. It's about the why.
I have another comment to the same thing, and in my mind, basically, maybe the basic things don't need to even change. When I think back on my own, let's say, career on risk analysis projects in consultancy in DNV, I had people around the table, and I always make sure or try to make sure that all the important stakeholders are around the table and that the risk issues are discussed. So that, in my mind, doesn't need to change. What needs to change is, point one, we need to make even more sure that really all stakeholders are around the table. And point two, it puts a heavy burden on this facilitator of risk analysis because you need to hear the people which are around your table. And you need to make sure that science and non-science is really balanced out, that you don't treat the non-scientist as no value or so, right? So that's more the human properties in making these facilitations, which become very important to do that properly. But basically, I think we can do it in this way, and that would probably be one way. And then you need to of course prepare beforehand the science numbers, right? So you need to be able to put them on the table and say, it would be the statistics about this and this, and what do we think about it? Is there anything to say about it, and stuff like that? So yeah, I think it's doable, but it's not easy.
Yeah, life is hard, they say. Thank you, Siegfried. So of course, this is an open discussion session, and it's not only for the panelists. So please do just raise your hand and talk. If you prefer to use the chat, that's fine. But you know, we can have this as a more fluid conversation too. Any takers? Anyone else?
Maybe we can just. I was reading was Pete's answer to question, Angel, when you ask about the difficulty around operationalization of uncertainty. Maybe Pete, would you like to comment on that? I think it's interesting.
Yeah, good morning, or nearly afternoon. Yeah, I think it's really interesting because I think the more complex the uncertainty context becomes, then the harder it is to operationalize. And I was really just thinking about a weather forecast where in the message it will say there's a 60% chance of rain in the next hour, and that's quite, well, relatively easy to act on. The user might wonder where the uncertainty comes from. Is it from a number of ensemble members in a number of climate model runs? Is it the uncertainty across the grid box or through time? Might it only be, or is it going to rain for 60% of the hour and not for the other part? So there's, you know, that, but nonetheless, that's at least, aside from those sorts of methodological considerations, a relatively simple piece of uncertainty information to operationalize, I think. But when we move to things like seasonal forecasts, it's almost entirely in uncertainty and confidence and probability. And we would be using messages like there is a higher than normal chance of experiencing a warmer and wetter 3-month period, autumn, compared to normal. So already you can see the messaging is layered up. And in the long-term climate context, it goes even further because, of course, it depends how far ahead you're looking, which emission scenarios, so on and so forth. So yeah, that was all I really wanted to add. And then, of course, there will be other uncertainties in the impacts and in the adaptation.
Yes, Angel, do you want to comment on that?
Yeah, if I may, Pete, I completely agree with you, but I was wondering if you are talking about more on the operationalization of communicating uncertainty, because indeed it's complicated. When you talk about the normal, then your baseline is 33%. And when you say normal, so then even like things like 50% compared to 33 is something, and people might consider that not high enough because they are expecting 95% or something like that. So, but it seems like that your comments are more related to communication of uncertainty, which is an very important key topic that we also are dealing with in Climate Europe too, and propagation. But I don't know, just so I am clear enough, I wanted to ask back, what do we understand about operationalization? If it's only communication, as it seems you are referring to, or if it goes well beyond that. I don't know if Siegfried or Andreas want to go back, because I think you were the ones asking that question. Thank you, Pete.
Yeah, thank you. Agree.
Yeah, hi. So I can comment. I think it's very important, like Pete said, that what do you mean by probability? That's one aspect of it. So interpretation and communication. But you also have, what is the source of the uncertainty? Is it that there is variability, real variation in the world, or is it lack of knowledge, something that you just don't know? So what is often called epistemic versus aleatoric uncertainty. That's examples of it. Also, certain uncertainties you cannot. So a probability is a way of expressing the possibility of more than one option, but it doesn't capture all aspects of uncertainty. So there are uncertainties that you cannot quantify, because whatever number, if it's a probability, whatever you give me, I can always ask, but how did you come up with that? And this is sort of an endless, you can ask that again and again, and you sort of, it ends up always with the qualitative assessment. Okay, do I trust you or not? And then it's a question of, okay, how do you transfer that knowledge? How do you convince somebody? How can I trust one? It's about the kind of ways of knowing, like you said earlier. So I think it's also about understanding actual sources of uncertainty and how it's actually, some uncertainties are possible to express with numbers. Some uncertainties you cannot express with numbers. I think it's important to realize.
Yes, thanks, Andreas. Actually, there's also an interesting comment of Christian who says that, it's both calculating and communicating. So, and now I will give the hand to Asun first. Sorry, Christian. Asun raised her hand first, and maybe you want to jump on your comment right after her. Please go ahead, Asun.
Do I go ahead? Okay. Thank you, Fanny. No, I just listening to this discussion and to all your contributions. Thank you very much. What becomes quite clear to me is that one of the biggest problems, and it has to do with the operationalization of uncertainty, but also the difficulties of really operationalizing the actual integration of different knowledge systems, is that it gets to a point where everybody needs to decide and we need to act, right? And there is always going to be remaining shades of uncertainty. There is always going to be that. It's impossible, and many are not possible to quantify. But here is where the hierarchy is about power relations. Werner will know what I'm talking about, right? But again, I'm the philosopher, not the social scientist. This is where different types of knowledge do not have an equal weight. And I think that's the problem here, right? When decision makers give a lot more weight to a particular result that comes from a particular way of knowing, which tends to be a priority and a prevalence of the quantitative, of the things that you can actually come up with a number, even if the number is meaningless. And I think this is one of the biggest problems. And I'm struggling as I think through the key questions of standardization of climate services and how to actually grapple with that. So if you could actually contribute to this discussion and to say something, that would be very useful, because I have the gut feeling is one of those areas where we are going to have serious trouble in Climate Europe too, to really come up with concrete guidance as to the standardization process, because it is also a huge risk that we decide, oh, things cannot be standardized, and then we don't standardize anything, which is also a big problem. Yeah.
Yes, thanks, Asuna.
Maybe I'm messing up.
No, that's fine. And it comes back to the question Werner raised after his presentation, how to assemble these different voices and these different ways of knowledge. So we have like less than 5 minutes left. I'll give a short hand to Christian and then to Carmen, and then I think we'll wrap up or conclude.
I'll be very quick. Just to say that Andreas really said about what I wrote in the comment. And just to say that if we want a climate service, then quite automated, so we need to calculate something. So that's the problem with the cascade of uncertainty I was mentioning. And communication is also a big deal, because you need to know how to present things, and people want an answer. And I would just end by saying that even with a lot of uncertainty, each country has a budget and they make decisions on it, but the uncertainty is very large, so it can be the same for climate services.
Yes, no, good to mention the constraints. Thanks, Christian. And Carmen?
Hi, everyone. Just very quick. Yeah, I agree with Werner and Asun that there is a power dynamic to be considered when talking about uncertainty in the different systems. But at the same time, I think it's also a matter of looking into what is the demand of each one of the communities, because as Angel and Werner said in their presentations, not everything it's valuable for the same demanded question. So not every single system can be applied to try to tackle that demand. It could be the indigenous knowledge might not applicable because the time frame or scale of that is required by the demand, and it could be the other way around, that maybe the scientific community wants to implement a specific time scale with high uncertainty that is absolutely useless. Well, it's useless for the community in practice. So the way to integrate both and maybe foster that trust that could lead into that, maybe not solve, but reduce that power dynamic that they were mentioning, is to bring them both together, because sometimes they don't need to be alternative, but they can be complementary. So we're looking at the examples that Angel presented, like action-based, focus-based finance or focus-based action. More often than not, you can combine them, both of them. Not easy in an easy way, because it's never going to be easy, but it doesn't necessarily need to be that difficult. When you co-develop and you talk to the communities, in need.
Yes, thank you, Carmen. Very interesting point. Charlotte, a very quick comment, and then I'll let Angel close the session. Sorry for that.
Thank you. Just something that I think Andreas captured at the end of his comment, which was that in the end, it's about, do I trust you? And somehow the users have to trust the information that we're providing.
Yes, thanks, Charlotte. So I think, we have less than 2 minutes left. So any other comments, or Angel, I'll let you the floor. I'm not sure if you want to address any other points.
Thank you, Fanny, and everyone. It has been another super interesting discussion, and it seems that we still need a lot more time for this. So it's time for lunch, actually, and at any moment the room will be closed. So let's take advantage of the hour and a half that we have. We will see you back at 14:30. And thank you very much to everyone, the presenters, but everyone participating and also like contributing through the chat and paying attention and listening to the session. Has been very, very exciting and fun. Thank you.